Hello guys. I'm in Ramakrishnan from BIT Vellore. Today I'm here to give a lecture on the topic nanophysics, which is in the module 3 from my syllabus. Let's go ahead. First, the introduction. What is nanophysics? Nanophysics is the physics of structures and artifacts with dimensions in the nanometer range or of phenomena occurring in nanoseconds. Nanophysics are the study and application of extremely small things and can be used across all the other science fields such as chemistry, biology, physics, material science, and engineering. Nanophysics is science, engineering, and technology conducted at the nanoscale, which is about 1 to 100 nanometers. It's hard to imagine just how small nanotechnology is. 1 nanometer is a billionth of a meter, or 10 power minus 9 of a meter. Here are a few illustrative examples. Well, first example is a sheet of newspaper is about 1 lakh nanometers thick. There are 2 crores 54 lakhs nanometers in an inch. On a comparative scale, if a marble were a nanometer, then 1 meter would be the size of the earth. Next, this photo shows the photo of physicist Richard Feynman, who is the father of nanotechnology. For example, how we will say Marconi is the father of radio waves, similar to that, this guy is the most important person for nanotechnology because he was the starting point where he found about nanotechnology. Next, the nanophysics involve the ability to see and to control individual atoms and molecules. Everything on Earth is made up of atoms. The food we eat, the clothes we wear, the buildings and the houses we live in, and our own bodies. But sometimes, as small as an atom is impossible to see them with the naked eye. In fact, it's impossible to see the microscopes typically used in high school science classes. The microscopes needed to see things at the nanoscale were invented relatively recently, about 30 years ago. I think so. Although the modern nanoscience and nanotechnology are quite new, nanoscale materials were used for centuries. Alternate sized gold and silver particles created colors in the stained glass windows of medieval churches hundreds of years ago, like the churches in Roman areas where colored panels will be there. That's quite an example of nanotechnology. The artists back then just didn't know that the process they used to create these beautiful works of art actually led to changes in the composition of the materials they were working with. Today's scientists and engineers are finding a wide variety of ways to deliberately make materials at the nanoscale to take advantage of their enhanced properties, such as higher strength, lighter weight, increased control of light spectrum, and greater chemical reactivity than their large scale counterparts. Well, now let's talk about the history of nanophysics. Here, the first use of concepts in nanotechnology was in here's a quote by Richard Feynman. There's a plenty of room at the bottom. Feynman described a process by which the ability to manipulate individual atoms and molecules might be developed, using one set of precise tools to build and operate another proportionally smaller set, and so on down to the needed scale. In the course of this, he noted scaling issues would arise from the changing magnitude of various physical phenomena. Gravity would become less important, surface tension and van der Waals force will become more important. This basic idea appears plausible and exponentially assembly enhances it with parallelism to produce a useful quantity of end products. The term nanophysics was defined by Tokyo Science University Professor Norio Tanguchi in 1974. Nanotechnology mainly consists of separation, consolidation, and deformation of materials by one atom or by one molecule. In the 1980s, the basic idea of this definition was explored in much more depth by Dr. K. Eric Detzler, who promoted the technological significance of nanoscale phenomena and devices through speeches and the books of Engines of Creation. The coming era of nanophysics and nanosystem, molecular machinery, manufacturing and computation, and so on, the term required its current sense. Engines of Creation, the coming era of nanophysics, is considered the first book on the topic of nanophysics. Nanophysics and nanoscience got started in the early 1980s with two major developments. Fundamental concept. Well, for example, 1 nanometer is 1 billionth or 10 power minus 9 of a meter. By comparison, typical carbon-carbon bond lengths or the spacing between these atoms in a molecule are in the range 0.12 nanometer to 0.15 nanometer. and a DNA double helix. DNA, where all the animals are, each and every organism in this world is made up of DNA. Even that DNA has a diameter around only 2 nanometer. On the other hand, the smallest cellular life form, the bacteria of genus Mycoplasma, are around 200 nanometer in length. So you can't even see that. Well, next we go to application of nanophysics. The project lists all of the products in a publicly accessible online inventory. Most applications are limited to the use of first generation passive non-material, which includes titanium dioxide in sunscreen, cosmetics, and some food products, carbon allotropes used to produce ecotape, silver in food packaging, clothing, disinfectants, and household appliances, zinc oxide in sunscreens and cosmetics, surface coatings, paints, and outdoor furniture varnishes, and cerium oxide as a fuel catalyst. Well, now we will talk about nanophysics application in different fields. Nanomembranes have been produced that are portable and easily cleanable systems that purify, detoxify, and desalinate water, meaning that third world countries could get clean water, solving many related health issues. It also has various applications in various different fields like medicine, chemistry and environment, energy, information and communication, heavy industries, and consumable goods. Now, we'll talk about its use in medicine. Nanomedicine seeks to deliver a valuable set of research tools and clinically helpful devices in the future. The National Nanotechnology Initiative expects new commercial application in the pharmaceutical industry that may include advanced drug delivery system, new therapies, and in vivo imaging. New electronic interfaces and other nanoelectronics based sensors are another active goal of research. Further, further down the line, the speculative field of molecular nanotechnology believes that cell repair machine could revolutionize medicine and the medical field. Well, even we could learn that this nanotechnology is used for treating cancer. Well, it's true. Next, we will go for chemistry and environment. Chemical catalysts and filtration are two prominent examples where nanotechnology already plays a role. The synthesis provides novel materials with tailored features and chemical properties. For example, nanoparticles with a distinct chemical surrounding or specific optical properties. In a sense, all chemical synthesis can be understood in terms of nanotechnology because of its ability to manufacture certain molecules. Thus, chemistry forms a base for nanotechnology, providing tailor-made molecules, polymers, etc., as well as clusters and nanoparticles. Next, we will talk about the energy. The most advanced nanotechnology projects related to energy are storage, conversion, manufacturing improvements by reducing materials and process rates, energy saving, and enhanced renewable energy source. Well, for example, even if you see Avengers movie, the Iron Man has used nanotechnology for his suit, which is quite a big example for this application of nanotechnology. Well, in the fourth case, we could see information and communication. Current high technology production processes are based on traditional top-down strategies, where nanotechnology has already been introduced silently. The critical length scale of the integrated circuit is already at the nanoscale 50 nanometer and below, regarding the gate length of transistors in CPUs and DRAM devices. On the fifth, we get heavy industries. An inevitable use of nanotechnology will be in heavy industry, such as the field of aerospace, construction, refineries, vehicle manufacturers, and so on. Next, in the sixth one and the last, it will come the consumer goods. Nanotechnology is already the field of consumer goods, providing products with novel functions ranging from easy to clean to scratch resistant. Modern textiles are wrinkle resistant and stain repellent. In the midterm, clothes will become smart through embedded wearable electronics. Already in use are different nanoparticle improved products. Especially in the field of cosmetics, such novel products have a promising potential. Well, next, we will discuss about some of the case studies. That is, about some carbon nanotubes. What are carbon nanotubes? Carbon nanotubes are also known as CNTs or allotropes of carbon. These cylindrical carbon molecules have interesting properties that make them potentially useful in many applications in nanotechnology. electronics, optics, and other fields of material science, as well as potential uses in agriculture, architectural fields. They exhibit extraordinary strength and unique electrical properties and are efficient conductors of heat. Their final usage, however, may be limited by their potential toxicity. Next, we will see how CNTs are made, otherwise known as carbon nanotubes. Well, it is made up with using two methods, arc discharge and laser ablation. In arc discharge, CNTs can be found in the carbon soot of graphite electrodes during an electrode arc discharge involving high current. This process yields CNTs with lengths up to 50 microns. Well, microns is 10 power minus 6 meter. And laser ablation. In the laser ablation process, a pulsed laser vaporizes a graphite target in a high temperature reactor, while an inert gas is inserted into the reactor. Nanotubes develop on the cooler surface of the reactor as the vaporized carbon condenses. Next, we will see some properties of the nanoparticles: strength, electrical, thermal, and of course, effects. Well, the strength properties. Carbon nanotubes have the strongest tensile strength of any materials known. It also has the highest modulus of electricity. Because of this, I think the strength of the nanoparticle helps it to produce more products with more rigid quality so that it is not brittle at all. Next, some of the electrical properties. If the nanotube structure in armchair, then the electrical properties are metallic. Well, you could see in the right hand side in the PPT, you could see that picture regarding the armchair structure type nanotube. If the nanotube structure is chiral, then the electrical properties can be either semiconducting with a very small band gap, otherwise the nanotube is a moderate semiconductor. In theory, metallic nanotubes can carry an electrical current density of 4 into 10 power 9 ampere per centimeter square, which is more than 1000 times greater than the metals such as copper. Well, next, thermal properties. All nanotubes are expected to be a very good thermal conductors along the tube, but good insulator laterally to the tube axis. It is predicted that carbon nanotubes will be able to transmit up to 6000 watts per meter per Kelvin at room temperature. Compared to this, copper, a metal well known for its good thermal conductivity, which transmits 385 watts per meter per K. The temperature stability of carbon nanotubes is estimated to be 2800 degrees Celsius in vacuum and about 750 degrees Celsius in air. And at last, defects. Defects can occur in the form of atomic vacancies. High levels of such defects can lower the tensile strength by up to 85%. Because of the very small structure of CNTs, the tensile strength of the tube is dependent on its weakest segment in a similar manner to a chain, where the strength of the weakest link becomes the maximum strength of the chain. Well, I would like to add a point about Dr. Murray. Murray is an important person in the history of nanophysics, similar to Richard Feynman, because he stated a law saying that the number of transistors will double every 2 years. As Mr. Murray had predicted, due to this technological advancements and nanophysics, even the number of transistors had become even more number of times, like double, triple, because when the size of the transistors decreases, more number of transistors can be compacted into a single microchip. Because of this, our computer technology has become has grown a lot. So, thus, I hope you liked my lecture. If you liked it, please subscribe it. Thank you.